Hi guys, today we are going to be treating a commonly asked question, tech interview question by top tech company including Google, Meta, Amazon, Netflix, and other top tech company. And the title of the problem is pair sum sorted. Pair sum sorted. So the problem statement goes thus. Given an array of integers sorted in ascending order and a target value, return the indices of any pair of number in the array that sum to target. The order of the indices in the result doesn't matter. If no pair is found, return an empty array. And we are giving some inputs and example inputs and a target. So, in this question, we are actually given an array of integers that are sorted in ascending order and a target value, and we are asked to return the indices of any pair of numbers in the array that sum to the targets. So this means that there is likely a pair of number in the array that sum up to the targets. If such pair is found within the array, we return the indices of those pair. You understand? Okay, by glancing through now, we can quickly look, okay, is there any pair of number? Pair means 2. Is there any pair of number that sum up to 7? Right, we can see 3 and 4 in the array, and they sum up to 7. So what they're expecting us is to, in the output, is to return an array of these pairs. Now, 3 and 4 corresponds to index 2 and 3. You understand? Minus 5 is 0, minus 2 is 1, 3 is 2, and 4 is 3. So we are asked to return that array and that list of indices. Now, how do we solve this problem? I'm going to be explaining the logical way, a very interesting way. You will really love it. Okay, now let's go. The most intuitive way to solve this problem is to consider all possible pairs and check if anyone is going to sum up to the target. You understand? So trying to consider every pair, every possible pair. We can consider minus 5 minus 2, we can consider minus 5 3, we can consider minus 5 4, just any sort of pair, and once we get to one that we evaluate the target, which is 7, we return it. Now, to consider all possible pairs, we are going to be using two nested loop. As we can see on this code platform, VS Code, the outer loop, which is this one here, will traverse the array, just like we can see it iterates through the length of the array n. So it will traverse the array for the first elements, while the inner loop, this will traverse the rest of the array. That's why we have it as I plus 1. The I plus 1 means now that supposed we choose a particular index 0, which corresponds to minus 5 in the list that is given to us in the example. I plus 1 is where J will start from. So it's trying to traverse the array right from where the first element is picked, so that it can try to check out for every possible occurrence. And what happens is that for each occurrence, nums of I and nums of j, if we find anyone that is equal to the target, it will return that pair I and j. Don't forget that I and j corresponds to the index of the particular pair that corresponds to the target or sum to the target. So, but in a situation whereby it exits the loop without returning anything, definitely it means that he couldn't find a pair throughout the array. This approach has a time complexity of O(n) square, where n denotes the length of the array. But we do not take into account that the array is sorted. Let's try and take into account that the array is sorted. Probably we could arrive at a more efficient time complexity, because one thing about coding interview in top tech company is that they are not interested in you getting a final solution. So they are much more interested about how you can code efficiently. This code now, there are tens of ways you can write it, but there are only few ways you can write it efficiently. So we are going to be taking advantage of the fact that our array nums, our array is sorted. we are going to take that advantage and look if we can arrive at a more interesting and efficient algorithm, so that we can have a good coverage of the array. Let's start with the elements at the extreme, meaning we are going to be starting with 5 and 6. So the technique we are about to use now, we call it the two-pointer technique. The two-pointer technique. So it's a situation whereby we'll be having 2 pointers at different position or same position in an array, so that they can keep track of different value. The benefit of two-pointer technique is that, instead of having to perform 2 loops, first for the first element and the second for the second element, just to compare these 2 elements of the same array, instead of doing that, we will position 2 pointers on the same array, and even just by one iteration, we can cover up all of anything we want to cover up, and we can also do comparison without any for loop. That's why we use 2 pointers. What do we observe? It is sorted in ascending order. Now, when we take the left pointer and the right pointer, the left pointer is currently pointing at -5, right pointer is currently pointing at 6. Now, when we find the sum, don't forget the question asks us to find any number or any 2 number or a pair of number that when we sum up will give us 7, which is our target. But when we sum this one up now, it gives us 1. -5 plus 6 gives us 1. 1 is less than 7, so we move our left pointer by 1. Why are we moving our left pointer by 1? Considering the array now, if we move our left pointer by 1, do you know what will happen? We will have a larger sum. If we move our pointer right from here to this position 2 or this position index 1, we will have a more higher sum because it is moving from -5 to -2, and that means a more higher sum, and that will give us something like -2 plus 6. So our target really, or what we are after, is to get to the target, which is 7, is to get an answer that is very similar to 7. And so by moving our left pointer to the right, we are going to get to a higher value or a higher sum and higher possibility of attaining the target 7. Now, on moving the left pointer one step to the right, we have a value of -2 at the left pointer and a value of 6 at the right pointer. The sum therefore is 4, but 4 is still less than 7. So what do? We move the left pointer again to the right. Now we moved our left pointer again to the right, and now we are currently at the index 2, which corresponds to element 3. Let's perform the sum now. Sum gives us 9. 9 is now greater than 7. Sorry, at this point we see 9 is greater than 7. So what do? We can move our left pointer again to the right by 1, because if we move it, it will just lead us to a more higher and higher sum. Because right now, if we move left to right, it's gonna be 4 plus 6, giving us 10, which is much more than 7. So instead, we are going to be moving our right pointer to the left. This time, moving right pointer from index 4 to index 3 is what we are gonna do. Right now, we move our right index one step to the right, one step to the left, and now we arrive at a left index or left value of 3 and a right value of 4. That sum up to 7, and right now we have our pair. So what we do is that we simply return the indices at which the pair evaluates or sum up to 7. Now let's consider a situation whereby the pair does not exist in the array. Don't forget the question on problem statement asks us to return an empty array if the pair of number or a pair of number that evaluates and sum up to the target does not exist. So let's evaluate how to do that. Right here, I modified the previous example a little bit by changing this 5, this 4 was once here, I changed it to 5. So just to show that, just to create an illustration of when the pair is not in the array. So at this point now, whereby left is at 3, right is at 5, we see that 3 plus 5 would actually give us an 8, and that is more than a 7. So we did not found the pair, therefore let me delete this. So alright, it is greater than 7, and what do you expect is that this right move one bit to the left. Why? Because it has to, if it should be left moving to the right, it will just make it even increase, but right have to move to the left, just like we did for the others. But now the right and the left are now situated at the same point. That means that we can never have a pair. Why? Because one cannot make a pair. This is 3 here, this is left and right pointing to the same index, and this, a single index, cannot make a pair. So therefore we cannot have a pair in this array. So what do? We return an empty array here. Now, having a logical understanding of this problem as it is, will enable you to be able to write it in several different programming language. This is all you need to know to solve this problem, and your interviewer will be super glad if you could explain it to him or her just like this. Now let's dive into the code implementation. We're going to be creating a function, def pair sum sorted array. Let's call this function because our array is sorted and we are trying to find the pair that we sum to a target. That's why I call it the pair sum sorted array. So the array will be nums, and that will be list of an integer. Why? Because it's gonna be containing an integer, and we also have a target, so which is an integer. That's it. So one practice I used to ensure is that whenever I'm programming, I deal with real data. So instead of just hard coding, I'm gonna write out the data -5 -2 is that 3, 4 and 6. So, and I'm gonna write the target that we're looking for. So this way we can work toward what we are actually looking at, not just hard coding. So now let's call it n to be the length of our array nums, and we are gonna define the two extremes that we talked about in the logic, which is left and right. So, and we are gonna put it at the extreme like we said. So, and the extreme for left is 0, which is toward the left, and right will be length of nums -1. In Python it is 0 indexed, so we have to reduce it by 1 so it can refer to the last index in the array. So we are going to be placing why left is less than right. Why? Because, you know, according to the logic, we say in a situation whereby left and right pointer points to the same index, that is, they become the same, we know there's no way of finding a pair out of the array any longer, because the left and right are now pointing to the same index. So at that point we are going to return and we are going to quit the loop. So while left is less than right, so far left is still less than right, we can find the pair. So we are going to continue now. We are going to find the total. Let's call it total. What is total? Is nums of left plus nums of right. So, and why do we do this is that we want to sum the element at left and right to check if it's equals to the target that is given to us. That's just why we are evaluating the total. So if it is equals to the target, what we do is that we return the indices at which the total become equal to target, which is index left and right. So, but if total is less than our target, so what we do, because it's less than it, we are going to be increasing our left by 1 so that we can arrive at a more greater sum or a more greater total. But in a situation whereby our total is greater than our target, what we do is that we increase our rights, we decrease our rights by 1, so as to arrive at a total that is smaller. You understand? Following the logic that we explained the other time. So, but in a situation whereby it returns out of the loop without it, or it breaks out of the loop without returning at this point, definitely, you understand, we can't find the pair, because the only way it's gonna exit the loop is when left eventually become equals to right or become greater than right. So, and at that point, we're gonna return empty list. So now let's call our function print nums, comma, target. So let's check it out now. So right here we have our 2,3 printed. So we have it printed here. Actually, it's not printed on a new line, although by printing something before this particular print here, we can force it to print on a new line. But you know, Visual Studio Code by default might not want to print it on a new line. But right here we have our index left and right index, you understand, which corresponds to 2,3. And if we look at 2, 0, 1, 2, it corresponds to index 3 and 4 here, and that gives us 7. Let's try for another input, nums equals to empty. Let's see. We could see it returns an empty array. So that's just it. You see, understanding the logic, understand. So it's just like you knowing what you want to say in your mind, and they ask you to write it down. It's just as simple as that. You already know what you want to say, then to write it down won't be a problem. That's what it takes, and that's the advantage of working logically. Now let's consider the JavaScript code implementation now for our JavaScript people and programmers. So you know, code is not so ambiguous. It's just syntaxes that are different between different programming languages. So it follows a very similar pattern, and one interesting thing is that one logic, different languages. So now you see in this function as well, we create our function, we pass in our nums and our targets, and now we define a variable left and a variable right to represent the two extremes, and we place our while loop to try to loop through once and while left is still less than right. And what we do is that we create a constant variable that we hold the sum, the current sum, and if the current sum equals the target, it returns an array of the indices. But if it is less than the target, we increment our left by 1. Otherwise, that is, if it is greater than the target, we decrement our right by 1. You understand, through the logic. And now in a situation whereby this return could not work successfully, you understand, that is, if it should exit this while loop without returning anything, definitely it does not satisfy the condition any longer, and the left and right eventually met, and it's gonna return an empty array. So you just have to do console.log, and similar things gonna work out. So you see, logic is very, very interesting. It makes work easier, and it makes work extensible into different languages. It's just like you're writing a pseudocode. So right now you can solve a problem that is commonly had by Google, Amazon, Meta, Netflix, and lot of Microsoft, Apple, and lot of other top companies. You are one step closer to nailing your next tech interview. So well done, give yourself a pat in the head. I give myself 2. So watch out, I'm gonna be coming with the next problem, and I'll be providing a solution to it. Let me give you a hint to the problem. I think it's gonna be some triplets. What did they call it? I think triplet sum, but don't worry till then. Thank you.